Okay, good morning, everybody. I hope you can hear me. Asaf, can you hear me?
Yes, Shlomi, I can hear you. Good morning.
Good morning, everybody. Some of you I know, most of you I don't. During this technical session, I will not be able to follow up the chat, meaning if someone raise hand or have a question, I will ask Asaf if you can follow up the chat, and if someone is raising its hand in the middle or even during the session, please let me know and I'll try to stop and answer questions. Generally, I'm giving rooms for questions during the session. So just bear with the scenario itself, and then we'll see how it goes. We will stay here between 1 and 1.5 hours. The demonstration is about 1 hour, what I want to demonstrate, maybe more. But then, of course, technical questions, I'm more than welcoming it. So just feel free to let us know. So I think we have waited for, I see people are still joining, but I think I don't want to waste your precious time, those of you that already in. So let me start, and then when people continue to join in, we will just have to follow up. My name is Shlomi. I'm the CEO of CIVILCAD Design. Thank you. We have a full house today, quite a big number of participants. This technical session, I will call it a technical session and not just a webinar, because I'm gonna go into details. It's those of you who are new to CIVILCAD. So CIVILCAD is a product that exists since 1999, meaning 22 years ago, whereas the current version, CIVILCAD 10, which is whole new development based on latest technology, .NET technology, was first introduced in 2018. Now, I'm going to use CIVILCAD 10.3. It's not yet in the market. It will be soon available in our website. So those of you which are already clients and under service will be able to download and update your system. And 10.3 includes some improvement, some bugs fixing, some new features. Some of them I will share today. Of course, I will not be able to share all of them today, but those of you that already know the system will be able to appreciate it along the way. About CIVILCAD. CIVILCAD comes in two flavors. It comes with CIVILCAD, and it comes with a flavor which we call CIVILCAD Z, which used to be ZWCAD Civil. So currently we don't have any more ZWCAD Civil. We call it CIVILCAD Z. It's the same product. So again, CIVILCAD Z and ZWCAD Civil is the same product. Again, let me repeat it again because it might be confusing to some of you. CIVILCAD Z and CIVILCAD ZWCAD Civil is the same product. Just to prevent confusion. What does it mean? It's the same CIVILCAD that most of you know and those of you that don't know. It's the same CIVILCAD, but it works with ZWCAD. CIVILCAD can work with AutoCAD 2019 and up. Currently 2017, but we are about to end up the support in 2017, and ZWCAD Civil, so ZWCAD, sorry, 2020 and up. This is what CIVILCAD supports. Any question about this one before we continue? Questions? Just let me know. Any questions? None.
Sorry, can I ask a question?
Please.
Regarding this CWCAD,
Yes.
is this independent or dependent to CWCAD and AutoCAD?
So again, you talk about this product.
Yes, correct.
It depends on this product.
Okay. So this means you cannot use in other product.
No, you can, if you buy this, you need to, you cannot, it doesn't work as a standalone. This is the question.
Yes, sir.
It does not. It does not.
Okay.
You need
Okay,
a drawing
thank you.
environment. In the past, it used to be standalone, but we abandoned this. We are focusing on the civil engineering and using one of the two engines. One, either this one or this one.
Okay, thank you, sir.
Other questions, please. Okay, we have 4 types of packages. We have the standard package. By the way, here you need, just to make it the standard, you don't need professional. This is what we need. Maybe it's more clear now. We have 4 types of, yes, please.
Sorry, sir. So you're saying standard only? It will not work in professional?
It will, but this is the minimum. Both these are minimum requirements.
Okay, understand. Sir, one more.
Yes.
Is this seminar is recorded? Can we get a record for this session?
Yeah, this session is recorded and you'll get, we will distribute it.
Okay, thank you, sir. Thank you.
Okay. So we have 4 types of packages. We have the first one, which we call standard. It's mainly for surveyors. It's include what we call coordinate geometry, everything that deals with coordinates. If you like, surfaces and contour lines. And it also allows you to calculate volumes. Earthworks. This is the standard. The second one is pipes, very popular. Pipes is for, it's a complete solution for for the water, sewage, and drainage designer. We have the roads. We have the roads. Which is obviously by name everything that we have to offer for the road designer, and we have the full package, which is roads plus pipes. Any question about this?
Hello. Sorry, I have a question about the gas pipes, gas communications.
Okay, gas falls here. Gas is a special feature that we developed, and it's come under the roads. So if you want the gas, you need this package, or of course the full package, one of these two.
And you are talking now about the outside area, but what about inside area, some regulation stations, which is inside the building?
No, we are not dealing with it. I'm talking about only infrastructure.
Ah, okay, thank you, thank you. Sorry, maybe I missed information, thanks.
So we don't have any solution for inside buildings, not sanitation and not gas. We're talking about infrastructure outside, like you call it.
A question.
Yes, please.
How about this district cooling? Are you familiar with the district cooling pipe?
The which one?
District cooling.
I'm not sure I'm familiar with the term.
Okay, thank you.
Maybe we have it in different.
Also,
you can write it down.
all right, okay, thank you.
Yes, someone asked, okay, is it like Civil 3D in Autodesk? Yeah, it's a competitor to Civil 3D. It has advantage, it has disadvantage. Obviously, those of you that know Civil 3D will see the differences. CIVILCAD works faster than Civil 3D. I can tell you, for example, for underground infrastructure, for sure, we are much better. When it comes to roads, it depends. When it comes to surfaces, it depends. So I don't want to do the comparison too much. I can give you just the highlight, but generally, yes, it's similar, but you'll see the advantages. More questions, please.
How about, sir, the specification?
Which one?
Specification regarding the for every unit, example, system requirements.
Okay. What are the minimum requirements for the
Yes.
system? Okay, we have it in our website, so I'm not sure I will be correct, but if I recall, for sure you need 60 gigabyte RAM. This is a must. Like every CAD software, a good GPU is recommended, although, but I'm not sure, it's not mandatory. This is mandatory. This is not mandatory, but it's good. Like everything in life, SSD would be recommended. So these two are nice to have, but this is a must. And about the CPU, well, it can work with i5. I would say i7 standard would do the job for 90% of the work. Like everything in life, everything better than this will work faster. For me, the most important thing is this one. Then probably this one, and then this a recommendation. It's not a must. Even an onboard GPU will work, but of course, it's strong GPU, what we call a graphic adapter, it will be better. SSD, like your computer. SSD today is much faster, but it's not a must. Okay, so let's not waste time. Let's go more into technical. So before I continue, this is my name. So if someone wants to write down my details, I'm also available in the WhatsApp. So you can always contact me, ask question. I'm here for you. And worst case, I will direct you to one of our technical support. Some of them are here with me today in the meeting. Yeah, so let's continue. Let's start. I see we have enough people, so let's not waste time. Okay. More coming all the time. Yeah. CIVILCAD. Let me start it. I'm starting it here. Okay.
Shlomi,
I'll press the icon. Yes, please.
can you see that everybody hears you from your settings?
What do you mean? I think I see that.
Because someone sent me a message through WhatsApp that he doesn't hear you.
Yeah, it's not something that I can do. If you hear me clearly, it's on his side probably.
Okay.
But it looks like the audience hear me well. I understand that you hears me well.
That's true.
Okay. So guys, I hope you can see my screen. I started the software. I'm trying to put the zoom on the side, but every time it's a challenge where to bring it. Okay, I hope you can see my screen. This is standard. In this case, I'm doing the demo with CIVILCAD 2022. You can see it here on the top. But it can work the same way it works like this. It can work with AutoCAD or Civil with any kind of AutoCAD from 2018 yet and up.
I'm sorry, but with the 21st CIVILCAD, it will work?
Sorry?
With 2021 CIVILCAD.
Yeah. Again,
Also good?
yes. As I said here, both.
Yes, I'm
This
sorry.
will-
Thanks you.
The
Mhm.
CIVILCAD standard 2020 and up. So definitely 2021 is good. 2020, 2022. In this case, I'm using 2022 and I'm using the professional. Someone asked me, but standard it will work the same. AutoCAD it will work the same. So this is how the system loads. Here is the menu of the CIVILCAD. Here is the menu of the CIVILCAD. Here below, you can see a coordinate editor. I can make it up. See, this is a coordinate editor. It's like a text editor, but specifically for coordinates. So before I will start anything, I will open a new project. And I will call this project, let's go to my CC projects, and I will call this technical session 1. And again, technical session 1. So I decided to open a new folder and put everything in this folder. Okay. So you can see we are now in CC project, technical session 1. You can see it on the top. This is the name of the project. And before we go into deep understanding of the system, let's start with easy things. I have a coordinate system and I don't know, a surveyor, a designer, whatever. And I want to put coordinates. I'm putting coordinates number 1. This is the easting. This is the northing. This is the elevation. and I'm putting another coordinates 50 on 50 and call it and put it here. If I click this magic button here, refresh, which I will use a lot, then the data automatically will be shown in the CIVILCAD, in the ACAD drawing. Again, it can be AutoCAD or CIVILCAD, it's not too important. You see, this is point number 2, this point. It's a block that the system puts. I can continue if I want. Yeah, you can continue and put another one, 1005 on 1010.56 with the elevation 102 and refresh, and then I will see it again. It's here. Nice thing is that for now, I just click enter points here and refresh to see it here, but I can do the vice versa. I can click here on the peak on the right below, click somewhere here or here, and you see there are new points, 1005, 1006 with the XY in this. If I refresh, I will see them, right? So how did I do it? Click and pick here, put a pot here, refresh. For now, it doesn't have an elevation, obviously. So let me give it some kind of elevation. Let's make it this one, 104, and this one, 106, and this one, 103. And refresh, and the points appear here. And now I want to create a surface, the contours lines. Out of this, I'm going to topography contours. I'm telling the software, create a contour lines each 25 cm. I'm doing it here on the right. Zero 25, and I apply. What I will get are the contour lines as per the points. In fact, what the system did, it created a surface. If I'll do show triangles and apply again, I will see this surface. This is the surface. See, there are points here for the surface. So the software did what we call triangulation and automatically create contour lines along the surface. The nice thing is that if now I will use the same thing here, which I used here, pick, and click somewhere here, you see that the coordinate which I received is already in 3D because the software knew how to extract the elevation from the surface. Again, pick, click here, and I get the 3D point which sits on the surface. Of course, I can take the point, stretch it a little bit, let's say make it 106, refresh, now it will go higher, and if I will apply, okay, everything change accordingly. So this is just a quick introduction. This is the main thing, just to understand the principle of the software. Let me just continue and show it a more practical scenario. I will start a new project. I will call it TS2, Technical Session 2. And this is the project, TS2. And now I will not key in the data, but I will load it from a text file. I will load it from a text file. How do I do it? I click here on this button here. I'm going here, and I have a coordinates list here, this one. You see, this is the list of coordinates. In fact, I have 4,630 points here. I can see it here on the right. If I click refresh now, all these points will be, you can see here the progress bar will be converted into the drawing. Let's give it few seconds, and very soon we'll get it. Of course, it's much bigger. Right, here it is. Okay, so the points which I had appears here. Yes, I can create. I create a please, everyone. Those of you that doesn't talk, mute yourself. Obviously, what I see here are all the points. Are all the points. Guys, please mute yourself. Okay. These are all the points, the same principle. Now, what I want to do is to load. I can create a surface out of it, but in this case, I also received 3D polylines that represent sidewalks, which were extracted by photogrammetric data. Let's see it. So I have it in AutoCAD, so I'm using regular AutoCAD commands, and this is the file. I would explode it in 00. Here it is. So these are 3D polylines. You see 3D polylines, which also falls in, which were extracted by photogrammetry. Why it's so important? Because they can affect the surface, make it more accurate. So now these are 3D polylines, but I want to convert them into break lines to make them affecting the surface. How do I do it? Topography lines here. Topography lines, you see there's a window. And I'm telling the software, filter. So the software asking me, what do you want me to filter? I'm selecting and I'm telling the software, it says, this is the layer you want to filter, break lines. And I see it's a polyline layers. I said, yes, apply. What the software will do now, it will, you see it here in the filter. It scans this entire layer and take all the break lines, sorry, all these polylines and convert them into break lines. I hope this is clear. In a minute, I will give room for questions, but let me just finish the session and then, guys, mute yourself, please. Okay. Nice. And now let's create the surface. Again, let's make it a rand 0.25 and apply. Now it creates a new surface. You can see it down below. The surface now for this entire neighborhood, which will include the points and the break lines. So give it a few more seconds and I think we should see it. Here it is. Just refreshing now. See, more people are coming in. Okay, so this is the surface of the entire area. Let's see what the break line did. You see, these are the break line. You can see it here. In fact, if I go to layers, I have a lot of layers here. Let me take all these layers of the contour lines, because I have different layers. Let's put them as a background, something like this, the background. And the major, I will do it brighter a little bit, maybe like this. And the break lines itself, let me make them something like this. Okay. So this is what we have. We have break lines. You can see, for example, here, all the break lines create the sidewalks on this path. You can see it's some kind of a path of a road that goes here. Here there are some probably different levels. So there's a jump here and here. Yeah. Any questions so far? So questions before I continue about what we've seen up till now?
Question, sir.
Yes, please.
Regarding the format, you put coordinates, right?
Yes.
What format did you save? The one that the surveyor give you the data.
Okay.
Possible we can do that also in Excel file or any files.
Yeah. So for your question, what I loaded now was a plant txt file, but we have many. We are supporting CSV file from Excel, obviously. We are supporting Leica format, GT7. We're supporting TopCon native. We are Trimble native. As I said, pure TXT is also okay. Comma delimited is also okay. Space delimited. Another guys, mute yourself. Now, another one can be, for example, you remember that I did filtering on the lines. I can do the same for points. I can take points and filter them. You know what? Let's do it together. Actually, let me continue. Let me show you something. First of all, this is the 3D. For us to see better, let me freeze this. I don't need it. Okay. This is the existing surface. By the way, you see it's written here below. I don't know if you see it. It says HT. It says HT. If I click this button up and go somewhere on the surface, let's remove the object snap, and click, I will get the elevation at that point, or this point. You can see it here. So now I'm working in a 3D surface. Now, maybe I want to show another scenario of loading data. In this case, what I will have, I want to show you how I calculate volumes. Someone did a pit here, a pit, excavations here, and I want to calculate the volumes. So up till now, I've used topography. Let me go to design coordinates. And in this case, I received the coordinates, not even in a text file, not in, I got it as a DWG. Let me try. So I will, again, enter a point which I received as DWG. Let me put them. Okay, I hope you can see. I've entered a DWG which I received from a surveyor. So this is another question. I don't have the TXT. I don't have Excel. I don't have, the only thing that I have is a DWG that I received. So these are the points. And let's see what I have here. I have the name of the point somewhere. This is the layer. And I'm looking for this point, which is the exact, this or the circle center is the same. For example, this one, I see that it sits on a layer that names PT symbol. Let's see what it is. PT symbol, and it's a point entity with X, Y, and Z. Excellent. So I want to use this layer. How do I do it? In fact, what I want to do is to convert these points into the points here, because I don't have it as a file. I have it only as a DWG. How do I do it? I'm going to general, filtering, tell the software, select which layer. Like I did with the break lines. I'm selecting this layer. It says it's a point in PT symbol, okay? Yes, okay. You see what happened? All the coordinates appear here. It went through the layer and create a file with points. So if I refresh now, I'm supposed to see it as a new layer on top. Yeah, you see? Exactly. It's not so important, it gives different name, but it's not so important for me. The important thing is that I have the points now. So now I can continue using them. How do I do it? I have the topography. Now I'll do design contours. Again, let's say 0.25 and apply. Okay, so you can see I have a layer, a list of layers which for the existing, and I have a new surface on top, which I call design, which is the pit. You see, this is the top, and this is the bottom of the pit. It means that if, for example, I would use again this button that I used before, and click somewhere here on the bottom of the pit, you see the difference. You see it here on the lower left. The topography is 68.35, but the design, the excavation is now at 65.44. So again, I created two surfaces, one here and one here. This one I call it existing, this one I call it design. Now I want to see the volumes between them. So I'm going to Earthworks General. On the screen on the right, I'm pressing apply. And I'm receiving the total cut. Here is 2,848.75 cubic meter. The total cut area is approximately 1,350. If I want to see it better in Excel, okay, now it's better, I think. We can see it in Excel. So I export it into Excel and press it. So the cut is this one. There's no fill, of course, it's a pit. Questions about this one?
Yes, can I have a question?
Yes, please.
I would like to ask about the surveying data importing. Is it possible to attach a sample block by coding survey data in the field?
Can you repeat the question, please?
I'm interested. Is it possible when you import survey data to your project to get symbols blocks by code?
Yes.
Yes.
Yes. The answer is yes.
And one more question. By code for some syntax is to measure and import after that break lines from the field. For example,
yes.
Can I code the line beginning of arc and the end of arc or something like, and when I import data to get break lines to surface straight from the survey data?
Yes. So the answer for both is yes. In fact, if you go here, you see there is another column. We call it code. You see? So with the library of code presetted in the software, you can also create your own set of codes. There's no limits. In fact, if I go to topography codes, these are the presetted code. You see, if I
okay, I understood. That's fine. Yeah.
But I can create my own, or I can create a break line based on these codes. Maybe you know what? I can even try to do something here. I don't want to.
Okay, don't waste the time. Just I'm asked about possibility.
Yes, yes, of course. I can
Thank
put
you.
here, for example, line, you call it alt 1. And that's it. And this is also part of alt. And then connect by that. More questions, please. Please.
If you use 10 by 10 grid to run your network volume,
Sorry?
using 10 by 10 grid run on general network.
Yes.
If you change the grid to maybe 2 by 2, the volume result is always different. Why?
Okay, so I assume the one that talks now is a user already of the software, that know the software. And the question, let me repeat, is that when I use here FOC general and I apply, so let's do it together. I go to volume 2000 guys, mute yourself, please. Mute yourself, please. Thank you. So let me repeat the question. The question was, here the quantity is 2,948, which the software calculates. It calculates this in what we call accurate system. Accurate system, it's a system where we, in fact, taking this, divide it into small grid. Like in this case, I think it's 20 cm on 20 cm, and make the calculation. Obviously, if I now want to display, and I'm using here create full grid, and I'm using a grid of 10 by 10. And I'm saying to the software, this is the area where I want you to create the grid. 3, 4, 5. Create a grid here. Okay. Let me zoom in. What the software did, it uses this frame to create a grid, which in this case is 10 by 10, because this is what I selected. And obviously each square has a number, and the volume is calculated by the existing minus the design is minus 926 plus minus this, multiplied by the area, we get the cut of this square. And the software continues to do it all over. Now, if I apply, see the table. The new table shows that it's a general force. You know what? Let me put it in Excel so you see it better. Okay, I hope you can see now. So this is a grid. It's 10 by 10. And each square that we see here on the drawing, sorry, let's show the drawing. Like, for example, square number 18 appears here, square number 18, and this is the cut, 283.66, which is the same which we see here. And then the software accumulates each 10 squares, and then gives the summary. All the squares from 1 to 10. This is the accumulative. Now, what the question was, you see, before it was 2,948, and now it's 2,936. And the question was, why is the difference? There's a difference here of 12 cubic meter, which is 0.5%, I think, in this case. Now, it's not always like this. Sometimes it's bigger, sometimes it's smaller. And the answer is very simple. In the beginning, when I used what we call accurate system, the system created a very accurate grid of 20 cm by 20 cm, or even 20. I can look at the configuration, but it's not so important now. It used very accurate system. And the results are very accurate. But in this case that we see here, the system used 10 by 10. So for example, it used 0 here, and the interpolation between here. So the interpolation started from here going down, and there is a pit here. So it's not the exact reflection of what's going on in the field. I hope I understood. Even if I will do now 5 to 5, let's change it to be 5 to 5. Okay, and it's too bulky. Let me change the scale of the fonts of the grid to smaller, make it fit for 150, and apply again. Okay, better now. So you see what happened here? Now it will be more accurate because the grid now is 5 to 5. It better reflect the actual surface. Obviously, when I make it smaller and smaller and smaller, it will be more accurate. But then we will get to the point which nobody will notice what's going on. So this is the difference. Obviously, the first one is the most accurate one, but the rest are those that we can present the calculation. You can choose whatever you like. More questions before I'm going to the next session?
Yes, sir.
Yes, please.
I want to add something.
Yes, please.
I'm interested about the explanation to cut the time about process the cut and fill in Contour. But for the earthwork, if we choose one point randomly, can we know the elevation?
Again, you want to know the elevation of a certain point somewhere here?
Yes, like randomly, I
Yeah.
choose one point.
Of course. We showed it before. So let me show. There are few ways to do it. Maybe I was not clear. Let me show it again. If I want to know the elevation here, for example, there are two methods. One, I can click here on this button on the top.
Okay.
I click here and I get the design and the existing. Sorry, the design and the existing. You see the difference? It's about 3 meters
Oh,
difference.
okay. For the comment is show the H status. Right.
Yeah.
All right.
I
Thank you,
can
sir.
also create a point here. If I want to create a point in the surface of the design, I'm going to design coordinates. Click pick here on the right and click somewhere here. There's a new point. You see here, point 1005. It's with the elevation automatically.
Oh, okay. Okay.
So now it's a text file already. I can save it as a text. I can copy it into Notepad. Here it is.
Okay.
How
Okay.
did
Thank
I
you,
do
sir.
it? I clicked here, pick, go to the surface and click, and then automatically it picks the 3D point and create a point out of it. I hope this is clear. More questions, please.
Okay. Thank you, sir.
You're welcome. More questions?
Okay.
Okay. Let me continue. So we saw how we created volumes between two surfaces. We also saw how we can extract points from the existing surface, from the design surface, and eventually, of course, we wanted to create the volumes to show the volumes between the two surfaces, and this is what we go. And then we saw different method of calculating the volumes. We saw the accurate system algorithm, the first one, and then later on, we saw other methods. I want to move to the next issue, unless you have any questions. No questions. Okay. So now, please bear with me because things are getting more, I don't want to say complicated, but more advanced. I will now design a new road that goes from here to here. Then I will add the new roads that will join it and a ramp which will go from here up to here. And then I will end up by designing underground infrastructure sewage network underneath. And if we have time, we'll do more things by questions. Yes, please, someone raise a hand. Please, Mr. Clement, go ahead, please.
Before we move on from general networks, please, I really need it because I'm using it for my work.
Yes.
When I use triangle to
Yes.
run my, there is, I want you to clarify on using triangle to run networks because here some people have the opinion of using general network. Some people have the opinion of using triangle to run network. As you as an expert, and like you know which one is the best to use.
Okay, so let me repeat the question. We are the question was introduced by someone probably that know the system, know the software, and what I understand that he wanted to know. So he asked me first a question about the earthworks volume between the accurate system and the grid, but now he asked, there's another method here, we call it triangles. Triangles, let me try it. I will have a mess here in the drawing. Okay. And let me try to freeze some of this grid. Okay. What I told the software now, calculate the volumes, but calculate it by triangles. You see there are triangles. So the system numbered the triangles of the design surface, and each corner of the design surface, the system, I can do like this. The system, see, it's a mess. Let me, there's a lot of data here. Okay. In each point here, the system created the existing, the design, and the difference in the corner, and then took the area of the triangles, and the same thing, calculate the volume. So if I go now to apply, I'll get a list. First triangle, second triangle, and the points that constitute it. Its cut area, its volume area, its fill, and the area, we have the projected area and the 3D area. So it will be a little bit different, depends on what we do. And the summary. So the total here is difference. And the question is, why there's a difference here when I'm using. Now, again, I'm going to the question. Let's assume, let me ask you a question. This triangle is by this point, and this point, which are the points of the existing, of the design surface. But if, for example, here in the inside this triangle, in the existing, there are points here, 6 or 7 points that create, let's say, a hill, a small hill here. This triangle will not reflect it. This triangle will not reflect it, because it's an interpolation of 1, 2, and 3. So obviously this is inaccurate. You ask me what is better? I don't know what is better. If you create demi points here in the design and then create more surface here, probably the triangles will be showing and reflecting the accurate, and will be very close to the earthwork general. But I don't want to say what is better, and I want to stop the discussion here about earthworks. I'm just giving you some hints, and want to continue and show more features. I cannot say what is better. I know that earthworks general is the most accurate because we create a very small grid that reflects everything, every change in the two surfaces. But obviously, if you create a grid by 10 by 10, it will not be accurate because the same goes here. But here in the triangles, we have the same problem. So what is better? It's a good question. Everything starts with earthwork general. It's the most accurate one. We are doing some trainings on earthworks, but this is not a training session. I can teach you more about that and how to perfect the triangles, because it's something that we need to be learning more. But let me continue to the roads. So I want to design a road from here to here. I will create a new layer and I will call it my center line. It's just a general ACAD layer, and I will make it the current one. And for my usage, I will give it this kind of color. Good. And my fourth road is going. So we see there is some kind of path or something here. I want to make it the main road. So I will start it somewhere here and continue up to here. This is the first center line of the road. Sorry, it's my mistake. Let me change it a little bit. I'm out, stretch it. This is the road, sorry, inside. So there was a path here, and now I want to create a paved road here. And the same thing I want to do is to go from here, from, let's say, nearest. Okay, sorry. Let's do nearest. Nearest here. And I'm using the polyline from the nearest. From here. And create another road which connect to this. I think this is already, it shows this path here. And the last one which I want to do is the ramp that start from here and connect here. So the last one that I'm doing, I want to connect to a road which goes here. Now the ramp starts somewhere here. Let's say here, no, after the junction from here, goes out here. Let's remove the object snap and connects to this road going here. Okay, so my first challenge, you will connect these two. Of course, a general arc will not do because I need to do tangents, right? So I'm using a set of tools which I have in CIVILCAD. Look on the top, you see a set of tools. And I'm using this tool. We call it line edge, line fit arc. It means that I'm using two lines to create the arc between them with the tangent. I'm clicking here. And the software said first line selection in the command line. Please enter to continue. Please enter to continue. I'm pressing enter. I'm clicking. This is the first one. So the system said second line selection. Press enter to continue. I press enter and select. You see what happened? The system creates an arc which the tangent point is from the end of the tangent line, previous tangent line, and found the interlink, the tangent point which connect to this continued road and create an arc out of it. In fact, it even shortened this polyline to make it accurate. I hope it's clear. So I have one center line, two center line, and third center line. I'm going into roads, going to my roads list, and the first one I will call it main. And the second one I will call it, this one I will call it S1, secondary one. And this one I can call it secondary 2. No, I will call it ramp because it's a ramp, so it would be ramp 1. These are the names. And now I'm going to the roads horizontal alignment. See the list on the right. It says which one is the first one. The first one is the M1. So I'll go to main, M. I'm pressing select. I'm going to the drawing, selecting this polyline, and tell the software, convert it into a road. So the software automatically creates an identifier. There are two IPs, one in the beginning, one in the end. And if I will apply, automatically, I will receive the road. So what I did, I changed this horizontal alignment into a road beam, in fact, the CIVILCAD, it's fully BIM if you are familiar with the team. So I created the surface of the existing before and another surface here. All of them are BIM modules. Here now I start creating a BIM of the road. So I have numbered the road, the cross section. In this case, the system used default of 25 meters between cross sections. Give it an IP here. I see the system uses text. I want to convert it into blocks. I'll go to options and tell the software show the IPs in block. Good. Another thing that I want to change, instead of calling the pipe the section 0, 1, 2, 3, I want to create them by their running distance. 0 plus 0, 0, 0, and so on. So let's apply the changes. Let's see. Okay, so now I'm converted to 0 plus 0.25, 0 plus 0.5, and so on. Good. Let me continue to the second road. I'm moving to the second road, which is S1. And I'm doing the same for second road. The same idea. So the system will obviously create the same thing from here. So this is the IP0 of road number S1, and this is of road M. And let's do the same here. I'm going to ramp 1, select. Now, every time I select, the software asks me, are you using a polyline, which is what I've used up till now. But now, I'm not using a polyline, I'm using segments of roads, right? Because I construct it with a segment, this tangent, this radius, and this tangent again. So instead of pressing enter, I will click S and enter, segments. Now the software asks me, okay, select the segments. So this is the first one, this is the second one, and this is the third one. And I press enter. Okay, the software said, I identify 3 segments. Automatically, I identified that this is the starting point. So it marked it as a red. But there are 2 other segments, this yellow one and this yellow one. And the data is shown here. There's an IP here, an IP somewhere here, with a radius of 99.473, which is what the software extracted using the geometry that we defined. If I apply it the same way I did it for the others, I will get my road with the beginning of the ramp. Here I have a curve, so I have what we call TC, the tangent to the curve, which start after 99 meters, 1 meter before this section. The data of the curve itself, the IP itself. And again, the tangent point from the curve CT, from the curve to the tangent, and the distance between closed sections. Okay, any questions up till now? Any questions up till now? I hope you succeeded to follow. If not, this is the time to ask questions. If anyone has a question, yes, please go ahead.
Sir, regarding this, you're doing the sample, these materials. Can we request this materials you're using?
Again, I don't understand the question of materials because for now I just created the center line. I've not.
No, regarding this, the coordinates, can we request for this copy, for the copy sample, because we don't have a copy for the coordinates.
I'm not sure that I follow. Again, maybe I'm missing something here on the question. So if you can just repeat, maybe it would be easier for me. Can you repeat?
Copy for the one that you put in the coordinates.
These coordinates?
What it means is that can you share all this so-called this particular coordinate that may be found is that may be coordinate. Can you share it with us?
You want to see these samples, you mean? This data?
Yes.
Okay, yes. What we'll do when we finish this training, this session, we will upload the movie and all the data also will be uploaded to the to our website, and then we send you a link so you can practice yourself. All the materials will be there as well. I hope this answers your questions.
Thank you.
Okay, all the data, now I understand. All the training materials, yes, we will share it with you. We'll upload it to our website as well. Let me continue with the road. So this is the road that I'm doing here. Let me just save the project for the data. Now, I want to design this road, road M. I'm going to roads, vertical alignment. Up till now, I used the horizontal alignment. I'm going to the vertical alignment. See what happened. There's a new drawing here. The first one was here, and this is a new drawing. And if not ramp, I'm changing to main road, M1, and I'm pressing apply. I'll immediately get the existing ground level of this road. I'll immediately get the existing ground level. So the software went along this road, extracted the data from the existing ground level, and I'm seeing it here. So this is the existing ground level. Also, the system identified two junctions, intersection. One that goes to the left with a road name S1, and one that goes to the right with ramp 1, which we know it's true because we have, right, the road start from here. So here we have intersection with S1 to the left, and here with ramp 1 to the right. So this is what we see. And we see the station for this intersection. Now, I want to design. I have a table to design, and I have a drawing to design. I can pick which one that I want. I can use both. So let me start here. I'll create a polyline, and I will start with the existing ground level. And in this case, I will just do a straight line up to here. So it's almost balance, cut and fill like this. If I will apply, automatically this polyline will be converted into a profile, and this is what we see. We see that all the data in the design appears here, each 25 meters, because this is the distance between cross sections. I can see that there is a slope of 0.8%. No, let's show it in percentage, and apply. 0.8% going here. Okay, so this is my design, and all the data automatically updated here, and this is the slope, 0.8, you said, all along. So this is my main road. The nice thing is that if I go to the horizontal alignment and tell the software to update, in each cross section, I'm supposed to see the height, the elevation here now. See? This is the elevation that I just designed along the profile. Now I'm going back to the vertical alignment and I will design this road, the profile of this road. If I go to S1 and press apply, okay, so this is the profile, the existing ground level of the road that we saw, this road that goes here. I see that it starts here. Here there's a fall, probably this fall. We saw it in the profile, here, this fall. And this is the existing. Now we see that it's connected to road M1. In fact, let me take this grid and give the grid yellow. So, you know, okay, good. So this is M1, sorry. And it shows that I'm connected to M at a T junction. We know it's a T junction, right? For S, it's a T junction. It goes here, there's a right and left. So in the beginning of the road, I'm connected to M as a T junction, the two flags. And this is where I'm connected at the beginning. But the nice thing is that I already see the elevation. Here is the profile, the elevation that the system got from the profile of M. And this is the elevation. So I will start my polyline from this connection point. And what I'll do here, I'll create it somewhere like, let me move the object snap, like this. Okay, from here, I'm doing another one.
Okay, thanks, sir.
Going like this, and another one that goes from here like this. I hope it's clear what I'm doing. I hope what I'm doing is clear. This is the new profile. It starts from the same elevation of M, the junction, right? This is the junction. And it continues like this, here and this. Before I press apply, I want to trim it. Otherwise, we have too many, this one, I trim this, sorry, this, and this one, I'm trimming this, and this one. Okay, so this is what I want, and now I can press apply and change these polylines into one profile. This is the profile. You see? This is the profile. So I'm going at 0.72% here, 7.71% here, and here. Now, of course, I need to create vertical curves. So let's create vertical curves here. This is 25 meter. Let's create 50, 60 meter. So this is the second IP. How do I do it? I'm going here to the table. This is, sorry, yeah, this is the second IP. I'm going here to the 2T. Enter the software, enter 60 meter and apply. Yeah, this is 60 meter. This is 60 meter. And here I want to do the same, but I want to try and use a trick. I don't know what is the length, but I want to stick to the ground. So I'm like, this is the third IP. This is the one. I'm clicking the button here, which I'm calling it arc through point. This one below here, arc through point. And I want the arc to pass through here. So the system automatically calculates that to pass through here, the 2t, the length of the curve has to be 71.68. Let's apply and see. Good. So now this is the curve. Yes, I see there's a raised hand here. Please. Any questions? Anyone want to ask a question about what we've seen up till now? This is the time, guys. This is the time, guys, to ask the question. No questions. No questions. Fine. Okay, no question. Let me continue. Someone asked me if a slope greater than 4% is safe. Depends on the speed and everything. If you go to San Francisco, you see 12%. Go to Jerusalem, there are some points of 12% as well, 11 to 12%. So it depends what is safe. 4%, of course, it's safe. Depends on what you are doing and what is the speed limit and others. Okay. So now the last thing that I want to do is go also to the ramp, apply. Now you can see a nice thing. Beside the connection, which is also a T junction for the ramp, we also see how M1 behaves. So the system gave us the profile of M up till a certain distance. Again, what the system did is to assist us. We want to see the profile of M projected on the profile of R1. And this is what the software showing us. Again, this is the profile of M projected on R1. Where do I set it? If I go to options, show nearby road. If I also want to see the elevation, I can cross here and I say 60 meters, for example. Apply now. See, it's much bigger. Now I told the system go 60 meters from the beginning. Sorry, go 60 or corridor of 60 meters from here. The software took offset to this side of 60 meters. Up till here, the software gave me the profile up till this point. Sorry. So anything that falls within the corridor of 60 meters, all the roads are being projected on ramp 1. So let's see the result. This is how M is projected. And of course, the tangent point where I'm starting the curve to the right. The data is also shown here, the elevation, you see, of M. If there are other roads, we see it as well. So let's continue. What I'm going to do, I will start with the same slope to ramp at the beginning, like this. This is the slope that I'm starting my road. In fact, I'm going to extend it up till this point. Extend. Extend it up to here. Okay. So this is how I start the ramp. The ramp starts with the same slope of the road and slowly leaves it. I'll leave it from here. Let's go. Sorry. Not good for me. Let's remove the objects now, like this. Okay. And now let's do what I did before, trim it. Trim. Sorry. In fact, what I did, okay. What I did, I told the software start the ramp with the same slope of the road. And then before the tangent, leave it. Go along here. Let's apply. And this is what I'll get. Okay. Here is it. Here it is. And of course, I need to do some kind of vertical curve. Let's make it 80 meter. Yeah. Here it is. Any questions, please? Any questions of what you saw up till now? Guys, don't be shy. Ask your questions, please.
Hello, Somi, it's Dimitris.
Yes, please.
May I ask something? How easy is it to make a change, let's say, if we need, let's say, to change the slope, we don't like the slope, and we want to have 2% perhaps.
For example, to change this.
Yes, is it something that we have to construct again the vertical alignment, or we can stretch a bit the axis to do this?
Okay. So the question was, guys, put yourself on mute. Put yourself on mute unless you have a question.
Coba kita tes buka file di sana.
Okay, so the question was, this is my road, and I want to change this profile from 2.4 to 2%. If I want to use exact 2%, it's very easy. You see the data here in the table? I go and change it. Instead of, it's exactly minus 2.399, which on the drawing, the system round it up because it's neater. I want to change it to 2%, minus 2, press enter and apply. Now it will go to 2%. See, everything goes up 2%. Very easy. If I want to stretch it on the drawing, manually I can do it. Take this, move it here. More than 2%, this will go probably to 3% or something. Go here, apply. Let's wait. Here you see, now it's 3.05, and I want to make it exactly 3. I'll come here, change it to 3, press enter, important, and apply. And the system will change it to 3. Questions? Is this what you wanted to see, Dimitrios?
Yes, yes, great, thank you.
Okay, so I hope this answers your question. So maybe I was not clear about this. Everything that we do here, we can correct it. We can correct it graphically by stretching, by moving, or we can go here into the table and enter data, like different elevation, exact slope. Both works for us. In fact, even the 2T here, it says 80 meter. If I click here on the column, it goes to radius, you see? 3,1820. If I want to change this now to 300 and 800, I change, and the software will calculate the 2T, the length according to the radius. Change a little bit. Now the 2T is 79.57. So there are many tricks. More questions, please. If you have more questions, this is the time. Okay.
I have a question, but it's in the front. You have not reached to the level. I don't know if I should ask now or when you get to the front.
Can you repeat?
I said I have two questions, but it's when you are at the cross section and when you're dealing with the supervision. Don't know if I should ask them now.
Again, in the cross sections, here, or you mean later on when we go to detail design?
Yeah, later on.
Okay, we'll get to it. This is, you are jumping ahead. So, yeah, you know what? Let's go for it now. Now, what I'll do, I'll continue with my design. Up to now, I've designed here. You know what? Just refresh the horizontal alignment. So all the elevation that we created up to now would be affected on the ramp. 1 second. Here it is. See, on the ramp, I have all the elevation. Nice. Okay, so now we have more question, and this question goes to the cross section. So let me deal with it. I'll go to the cross section. In what I'm going to do, I'm going to design the cross section of this road, and I make it a median with 2 lanes and 2 lanes and a sidewalk. Go to the cross sections. So here I'm going to the cross sections. It's important to understand that the cross section is an independent window. See it here. It's an independent window. It sits here. And this window have this section. It has the drawing section, the cross section list, and 2 tables. This table for now shows the existing ground level and the design, what some of you might refer to as subgrade, earthworks. But there are many tables which I can flip. For example, I want to see the structure, I can do like this. Or if I do design and I want to show the structure here, I can use it like this. So in fact, I can show 2 tables, no matter which of the table, both in the same times. Either on the left side, on the right side, the same. So for my ease of use, I will split my window. Sorry. So the profile would be on the left and the cross section would be on the right. And since I'm dealing with cross section, let's make more space to the cross sections. It's better for me like this. Okay. So now I'm on this road that we see on the right, on the left, and I want to design the cross section. So first, sorry, so I'm on road number M. Let me move to road number M. And what I'm gonna do, first of all, I'm telling the software, split the road into 20-25 meter like we know. So we have the table, show the table. So we see, we have the list of cross sections here on the table. So I'm standing on the first one, this one. Now I want to tell the software, go 20 meters to the left, 20 meters to the right, and give me the existing ground level. But 20 meters is not enough, so I'm going to the options and change it to 25 meters to the left and 25 meters to the right. So I can see what's going on here. And I'm telling the software, get the data. So the system went each 25 meters. Here is the small hill that we see here. This is the one, this is to the left and to the right. And it went 25 meters to the left, 25 meters to the right. I'm on section number 0. If I go to the next section, this is 25, and so on. I can, with the mouse click or with the button click between cross section and get the list of all my Okay, so I got the cross sections. Now, yeah, someone is unmuted, please. Now what I'm gonna do, I'm gonna stand on the first cross section and I'm gonna read the template. So I press here, load. I'm going to documents, CIVILCAD 10.3, templates, go to urban road street and go to main street with 4 lanes and a sidewalk. Here is it, here it is. So the system automatically took the 4 lanes with a sidewalk and read the template here. Let's see what I see in the template. I see a median of 2.5 meter with a slope of 2.5%. I saw a fall here of 15 cm. Then 7.3 meter asphalt. Then again, side slope, sorry. Step to the sidewalk, which is also 2.5 meter with 2.5% going to the road. And the same goes to the right. Any questions so far? I'm using this template. Someone raised their hand. Yes, please, go ahead. Unmute yourself and ask the question, Mr. Olwasesen. Yeah, what is the question, please? You have to unmute yourself.
My question is that are we not supposed to use the design level of the vertical alignment to do the design of the cross section, sir?
No, of course. What we did.
Hello?
Yeah, of course. We use a template. And the templates use the profile. This is the elevation from the profile. We see it on the top, 71.95 of cross section 0.
Okay.
And comparing to it, we're using a cross section which starts in the 0 point. This is the crown level, and I'm starting 50 cm above the crown level. See, 0 plus.
Okay.
Yeah, of course.
Okay. All right, thank you.
Okay. Okay. Now let's continue. I'm using this template all over my road. So I copy it, go to my last section in the list, this one, and paste. So this how it looks in the last cross section. Okay, and now I interpolate. Now the system projected this cross section all over. So this is the first one, second, third, fourth. We can see what is happening to the road all along. In fact, if I'll split it again and press create layout with the Chrome tools and apply, let's see what goes here. See on the left. I get the full information. So what I received here is all the data. Let's see it bigger. Let me freeze the background. Yeah, now it's better. Okay, so what we see, the median that we designed, left lane, right lane, the classic camber with contour lines along and the sidewalk. We also see that the side slope here is 2.5% going to the right and to the left. So the system took everything and created a layout. Fine. Now, I want to continue. On the left, there will be some plots development. So I'll leave it as it is. But on the right, I want to create a drainage, a side ditch, a concrete ditch going here on the right. Let me go to the cross sections. Okay, so what I'm doing now, on the right side, let me go to this. Here, I want to create a ditch. On the left, I'm not touching now because there will be a land development here. But here, on the right, I want to create a side ditch. How do I do it? Okay. Okay. Someone asked me what's happened if the road changed the width. There are many ways how to do it. There's a method named extract, but I can even change a specific segment. You know what? Let's do a sample here. Take this 375 and 80. I'm going to 375. And what I'll do, I'll take this and instead of 7.3, I'll make it 8.3. So before I continue to the ditch, I'm answering a question, how to change the width of the road or to deal with a road which is width change. So let's assume that before the ramp, the road is widen up here from this section, from section 0.175. So I'm going to 1.75. And what I want to do is on the right, sorry. On the right, I'm going to widen it up from 7.3 to 8.3. I'm going to the structure. This is the 7.3. I'm changing it to 8.3. And I'm making sure that the slope still remains 2.5. Airfox has to change a long way, the subgrade. Also, I have to open up the subgrade here. So here this is 7.5 because it's 20 centimeters inside. So again, 1 meter per. And the same minus 0.5. Let's see it. Here it is. See? Now this section becomes wider. So starting from here, the road will become wider by one meter to the right. But for now, I change only this cross section. If I want to project it from here going forward, instead of going section by section, I just click here on the line, right click, and press send to. And I'm sending it to all the section going from 200 till the end of the road. And I'm so doing the same for the earthworks. From 200 till the end of the road. Now I will, first of all, refresh all the cross sections. So let's see that everything is okay. 200, yeah. And I want to, so all the sections become wider. And now if I will update the layout, Let's see what happens. From here. 1 second. You see? The road is becoming wider. From here, we can see it. See the right lane? Maybe we have a mixture of the existing. Let's remove the existing. You can see that the road becomes wider to the right. I hope this answers your question. See, it's wider here. Start before the ramp, go wider here. Let me continue. So the topic was how do you deal with barring roads with transition toppers? Okay, I need to create transition curves here. Generally, it's the same idea, which I can create a transition here. And here I will create the same thing, do it from here with a super elevation, which I will not deal with it now. It's not a fully training, just generally there's a super elevation going here. You create the geometry here. I have nothing to show because there's no super elevation on this road. So if you would like to join the next training which we are doing, this is not a training. It will be done in another time, probably middle of the year. Let me continue. What I'm doing now, I want to enter a right ditch. So I'm changing this table to right ditch. But before I continue, I want to tell the software, first of all, don't end up the cross section like this. So let me go back. Sorry. Let me go back to the design. Before the ditch, I want to tell the software the subgrade should be open up here. So open it up in cut 1 to 2, fill 1 to 2. See, so the software opened it up in 1 to 2 here. But still, now I want to complete. This is not good enough. I want to create right ditch. So I'm telling the software, the left embankment of the ditch is 1 to 2. The right embankment of the ditch is also 1 to 2. The bottom of the width of the ditch is 0.6 meter. The depth of the ditch, if I'm in cut area, make it 0.5. If I'm in fill area, okay, I can decide there is no ditch or also 0.5. But I don't want now about two kinds of ditch that's continue from the side stick, or if it's a concrete, stick it to this point, this control point. So I want to stick it to not to the existing ground level, but to the end of the structure here. Let's apply. Here it is. This is the ditch. Here I have a problem because the structure itself did not slope, so I have to tell it also stop the structure. Okay, now it's perfected. So what I did, I created a ditch with 0.6 bottom, depth 0.5, 1 to 2, 1 to 2. If I'm happy with this ditch, now this is only on the first section. Now I have to project it to the rest of the road. How do I do it? So first of all, I will project this data that we changed. How do I do it? I click on the data that I want to project, click it, and then right click and send to all. And doing the same for this. All the things that I've changed, I have to tell the software where to project it. Also on the design, right? This one. Okay. And the ditch itself, of course. Good. Let's rebuild. Now, using this definition, the system created, you can see I'm clicking on each section and I'm getting the side ditch. If I want to see it on the layout, on the left, here. So this is the ditch. This is the ditch. Let's give it a color. So this is the ditch and the flow direction and all the data of the ditch itself. It goes here and continues. Good. In fact, if I go now to the profile of this road, the system automatically add the ditch invert level on the profile, and the data will be shown here. I hope this is clear. Yes, Mr. Clement. Yes. Unmute yourself. Yeah, please.
The way, let me say there's supposed to be. There's a way you can add your drill level and the profile that you are right now and send it to. But I always have issue with it. Sometimes it will send, sometimes it will not send. So let's go to clarify.
Okay, I cannot follow, and I said this is not a training. It's a technical session to show, but you are talking about sending. As I said, we will do an online training session in probably somewhere for June, so we can do practical things. But most of the audience here wants to see more of technical. But you're saying sometimes it sends and you don't know what it sends or not. We can join the training and then we'll do it together and we'll see. I'm more question, but regarding the capabilities, and that's about. Now, oh, okay. So we design our road. I can see the volumes of the roads. These are the cross-section volumes of the road. I can see the volume of the ditch by itself. So only the ditch. So this is the road. This is stripping, which is 0. And the ditch volume. As a separate. Someone asked me how does it work for gas pipeline. I'm not sure we'll have enough time today to do pipe guideline, but maybe it's good to talk more about gas in another. I think we have some kind of webinar on that. I'm not sure, a tutorial on gas. I'm not sure. Generally on pipelines, on gas pipelines. In the profile, everything changed. You have for the curve of the pipeline, with it hot, cold, or I forgot already. Elastic curve, an arc, but again, I didn't prepare a scenario for that today. So if you like, I can show it in a different time, but not today. You can write us an email and maybe we'll have a separate session for pipelines, for gas pipeline. I mean. What I'm going to do now is other pipelines, sewage, as I promised. So let me bring the ground level again, so I know where we stand. And okay, better. And this will be the last part of the session. It's where I want to create a network of sewage. And I'll do one which goes like this, and another one that goes like this. So let's start, let's create a layer. And I'll call it my pipe. And this is my layer. And I make it reddish like this. But what I want to do now, okay, this is 65, 50. This is 71, so let's go like this. Okay, so I'll create one center one collector. Let's say there's this way it goes to treatment plant. So there's a collector goes from here, and another pipe which goes. Cannot be like this, of course. So a collector with 600 millimeter goes from here to here, and I want to create manholes each 50 meters. Boom. Good. 50 meters. And there's another one which goes from here. So let's make it connecting. Here. And let's say it goes into the road here in the asphalt, and from here go along the road up to here, and again, and this time I'll do 25 meters between manholes, because this will be a smaller pipe. Okay, so this is the one. So I have one here, which connects here to the collector. Nice. Pipelines list. And I'm saying I have a main one. This is the first one. I'll call it collector. And it's a sewage pipeline. And the pipeline itself has a round profile. And I will use for diameter sewage with millimeter. I have a second one which goes along road number M, so I'll call it also M sewage, and it's also a sewage with round profile. Good. Then I have the layout, and let's start with the collector. For now it's only polylines. I want to convert them into pipelines beam model. I select the collector, and this is the select collector. Okay, what the software shows is that each vertex was converted into a manhole. Let's see, you see? Each vertex like this has been converted into a manhole. What is the size of the manhole? For now, it's just a default because we didn't define any. What is the diameter? We didn't define, so just default. So the only thing that we see is just the manhole with name of the pipe and the name of the manholes, 1.2, 1.7, 1.6, and so on. What I'm gonna do now, you see, I can move here on the right, and we have two more columns, pipe diameter and manhole diameter. So I'm telling the software, this one is 600 millimeter. Remember, I choose to work with millimeters here, so 600 millimeter. Now I can choose to do it all over, or I don't need to, because once I do it in the beginning, it will project all over. And I also want to give size to the manholes. So in this case, the manholes are all in centimeter 250 cm. And I apply. So you see, the manholes become bigger at 250 cm. And the sewage pipe itself also bigger to reflect 600 millimeter. And the data is here. Also, the data appear here. This is the 600 millimeter and the length between the two manholes, 50 meter. Questions up till now? Someone asked me to train him how to do the send to. As I said, I want to move on. For generally, just for your information, to do send to, you stand on the cell that you want to send, you click in it, and then you right click, it automatically will tell you send to. Then you choose which section you want to send to, and it would automatically send to this section. Questions about the sewage? Questions about the sewage up till now, before I continue? Yes, please. Yes.
Hello, sir.
Yes, please.
Sorry, how do you increase the size of the pipeline, sir? As in the you give the pipeline, sir.
Okay, as I said, after I selected the pipeline, if I move here, if I moved here on the right, scroll,
okay.
I have two more columns, one for pipe diameter and one for manhole size.
Okay. Thank you, sir.
More questions, please. Questions, please. None. None. Okay. Now, I want to continue. And I want to design the profile of this switch. I'm going to pipeline, sections. Now what happened, this is a new window. And another instance of the DWG will be here. So just for you to understand what we are seeing, this is one DWG. And this is another DWG, which is the section 1. So I press apply, and I get the existing ground level. So this is the existing ground level with all the data, ground level data, and the distance, and the manholes. I can design from the DWG, but it would be much easier to design here from the table. So we see the table. All the manholes are here. The station are here. The distance is there. The diameter that we enter is here, and the manhole diameter is also here. Also, the system for my assistant shows me here the top level and the top level slope, how this goes. So I will start with here with a depth of 1.5 meters. I'm going here to the depth of the first manhole and enter 1.5 meters. And press enter, the system automatically calculates the invert level. And I want to go parallel to the ground, more or less, up till this point. This is 300 meters from the beginning, is this one, right? Manhole 1.7. I'm coming here and pressing also 1.5 and enter. Once I enter 1.5, automatically the system calculates the depth. If I press apply, sorry, it's my mistake, 2.4 slope, sorry, I'm working with a slope, 2.4, press apply, and this is what I got. So I went 2.4% from here, started with 1.5 meter depth up till this point. And from here, I want to continue and going down here. I would go down here at minus 3.5%. Apply. Okay. So I started 2.5 for 3.5% here. But here, there is a problem. Why there is a problem? Because I'm exposing my pipe. So what I'll do, I'll create drops here. I go to the drops and create 2 drops of, let's say, 0.8 meter. And apply. So I created a drop here and a drop here. 0.8 is not enough. Let's make it 1 meter drop. Still not enough. Maybe the slope, I break the slope. So let's continue. Minus 3.5. Good. Now I'm good. So this is 3.5. Now, since this is a drop that goes beyond 0.4, it created an external drop here. You can see it. External drop here. Questions about what we've seen so far? Questions about what we've seen so far?
Question, sir.
Yes, please.
So in case we have a intersection, other pipelines, so we can adjust also.
Yes, of course.
Of course, we need to avoid the collision with it within the pipe.
Exactly. There's something mechanism called crossings, and then it will project it, and then, yeah.
Okay, thank you, sir.
In fact, not just that we can avoid in the design, or can tell the software automatically to check the crossings and automatically alert us when we are crossing our infrastructures.
The kind of Agile system is common abroad.
Sorry? Hello? Okay. Now, I will go to the, okay. after I finish this, if I go back to my drawing, sorry, go back to my drawing. Oh. Go back to my drawing and go to pipelines, layout, and update the layout. All the data will appear here. Okay, the top level, the invert level. Okay. Okay, now it's better. The top level, the height, the invert level, and so on. Now I want to continue and do the same for the M pipeline. M pipeline. So I go to sections. Again. And go to M. Okay. Now, and press apply. Okay, sorry, I didn't choose them. I'll go to pipelines layout and do the same. Tell the software, M is this pipeline. Convert this polyline. So the software did it. And I tell the software, see, this is a wider, sorry. The pipe diameter is 400. And all the manuals are 150. Beside this one. So all the manuals here are smaller, obviously, than this one. So this is line number 2. Now I want to extract the data, not just of the existing, but also the design. So for this, I need to take the road and create its surface as a B model. How do I do it? Let me go back to the road, go to M, apply, and this check the triangles. Triangles create a surface out of the road. 1 second. Might take a few seconds. All right, it was fast. Okay, now the road is also a 3D model. So if I go to the pipeline section of this new pipe, I will apply, I will first get the existing data. There's no data here. Okay, there's no data here. So for now, I cannot get it. Let me continue with the collector. With the collector and show you quantities. If I go to reports, and I'm telling the software, apply, I will get the reports of the manuals. So these are all the manuals, the dimensions, their height, the input level, and the outlet level, and the coordinates. So this is the report. If I want, I can even put it here somewhere. Okay, all the manuals are that appear here. I can do the same for quantities. If I go to quantities, so I have only the collector, apply. You see, 600. So for the mod, okay, let me put it in Excel. It will be easier to see. So first of all, depth pipelines Okay, I've not entered any materials, so there's no material here, but it says from from 0 to 100, there's nothing. From 1.76 to 2.25, 200 of meter of the pipeline is buried. 100 meters here and 100 meter here. Manholes of size 250, we also see. External drops, we have like this. Any questions? Because we are almost 2 hours already. So unless you have any questions, I've done for today. I want to thank you all for participating. Just for you about the software itself, we have a new plan that very soon will be available in the website as well. We call it an installment plan. It means that you buy the software. We are selling the software as perpetual license, not as a. We don't have any subscription, only perpetual. But we have installment plan. It means that you can take the software and buy it over 3 to 4 years, depends on the package that you buy. It means that you pay annually for the software, and after 3 or 4 years, the software is yours. Actually, it's yours before, but you have to complete the payment. So you can use it alone, and you pay over 3 or 4 years. It's a new installment plan. We already shared it with some of the distributors. You can ask them. It will also be shown in our website very soon. Thank you, everybody. Enjoy the rest of the day. Bye-bye.
Thank you. Thank you. Bye.
Thank you, sir.
Thank you, Shlomi.
Thank you. Goodbye.
Thank you. Hello.
Thank you. Goodbye.
Thank you.
Thank you.
Goodbye.
Goodbye. Hello,
Thank you.
bye.